Hi everyone, my name is John Park. Thanks for coming to my talk. I am based in San Francisco. I work on a team called ML Infrastructure at Airbnb. And today I'm going to talk about BigHead, which is our end-to-end ML framework. So our team was formed back in 2016 in Q4. The situation in 2016 at Airbnb around machine learning was that there were only a few major models in production. Models usually took on average of 8 to 12 weeks to build. Everything was built in Aerosol, which is our in-house machine learning library, Spark and Scala. There were no support for TensorFlow, PyTorch, Scikit-learn, or any other popular ML libraries out there. And the biggest problem probably was that there was a significant inconsistency between the offline and online data. And our team was built to enable more teams to build products with machine learning. And we really wanted to reduce the time and effort to build and evaluate a machine learning model. My team's vision is that Airbnb routinely ships machine learning powered features throughout the product, and our mission is to equip Airbnb with shared technology to build production-ready machine learning applications with no incidental complexity. I'll get into that a little later. So this is what I think the value of our team is. A machine learning infrastructure team can remove the incidental complexities by providing generic reusable solutions. And we can simplify the workflow by providing the tooling libraries, environments that make the machine learning development more efficient. As a result, if you have a machine learning infrastructure team in your organization, you can establish a standardized platform that enables sharing of the feature data, the model components across different teams. Basically, it makes things a lot easier to do and also do it the right way. So before our team was built, machine learning already had a big impact at Airbnb. Some of the examples are search ranking, smart pricing, and fraud detection. But after our team was built, we realized that there were a lot more opportunities that we had not explored, such as paid growth, listing classifications, group type categorization, business travel classification, message intent, and so on and so forth. So the motivations of our product. So in the past, we've learned that there's no consistency between machine learning workflows. We also found out that smaller teams were struggling with investing in machine learning. And Airbnb had a wide variety of machine learning models. By that I mean not just in different products, but also in terms of like the model types, like their image models, text models, built using the tree model or neural network models. And we also realized that existing machine learning workflows are very slow, they're fragmented, and they're brittle. We also wanted to make a distinction between the incidental complexity versus the intrinsic complexity. So, for example, machine learning itself is an intrinsically difficult problem, but majority of the time that people were spending were on the incidental complexities. For example, like setting up your dev environment to make sure that you have the right CUDA driver installed and CUDA runtime installed. If you're a data scientist or engineer, you know what I mean. And there were a lot of work that were being done in an ad hoc fashion in feature engineering as well. And this tends to lead to a result of build and forget model where it is a linear process instead of a cyclical process that we would like to see in the machine learning modeling process. So by cyclical process, this is what I mean. We jokingly call this the conjoined circles of ML. You can start from the top where it says data management. This is where, aka it's feature engineering. You collect all the data that you need for your model, and then you go into the training phase with that data. And once you've trained your model, you can productionize your model. And then you need some kind of a tool to manage your models. By that I mean you want to track the history of the model development. You want to have a record of all the past iterations of your model. And you also want some monitoring tools to see how the model is performing. And once you've done that, you don't just stop there, but you should really take that results back into the data management cycle so that you just keep iterating on the model so that model can evolve as the time goes. So I'm going to go into more technical parts of our product. I'm going to start with the architecture. So some of the design decisions that we made early on is that we wanted a running time environment consistencies. We wanted all the Docker images to be versions so that wherever you run your model, we wanted them to produce the same results. For that, we also needed a consistent data transformation. We wanted a tool that could do a multi-row aggregation in the data warehouse. And then we also needed some code, library code that could give you consistency in model transformation. We also wanted a common API to wrap all the major popular libraries out there. For example, XGBoost, TensorFlow, MXNet, PyTorch. These are all very popular libraries, and every data scientist and engineer have different needs to build their data. But we also wanted an abstraction layer where we can easily train and store models in parallel if needed to be. We wanted our stuff to be also modular so that it's easy to very customize different parts, and also to share the data in pipelines with other people if needed. So these were the components that we came out with. The first component is the data management. We call it the zipline. There's a training component, which happens in RedSpot and BigQ. We have the core machine learning library, which is called Bacon Pipeline. For productionizations, we have two components. For online, there's DeepDot. For offline, there's ML Automator. For model management and monitoring, we use something called Bacon Service. And this is what it looks like in practice. So in the middle, you have the Big Head service coordinating all these different tasks. On the left side is what's happening in the offline world. On the right side is what's happening on the online world. Offline, what's usually happening is that you're doing data management via zipline. And you have ML Automator, which is your scheduled scoring and training platform. And RedSpot is your interactive Jupyter notebook where you can train models, get access to special hardwares.